All right, go ahead and have your books open to page 179. I want to take a look at just a few questions with you. We'll answer them together as a class. Top of the page, there's some review questions here. Number 13 says, what's the name for an 8-sided polygon, class?
Octagon.
An octagon, O-C-T-A-G-O-N. Number 14, what angle is the complement of a 30-degree angle? Well, begs the question, class, what does complement mean?
90 degrees.
It finishes adding up to 90, right? So if I've already got 30 degrees, how many more degrees are needed to hit 90, Kirsten?
60 degrees.
60 degrees. That would be the complement. What if it had said supplement? Well, then I wouldn't think what adds up to 90, class. I think what adds up to 180. What would be the supplement? 150. All right, number 15. What word describes polygons that have the same shape or same size and shape? Jalen? Congruent. What if it had just said have the same shape? What would I put then for my answer, Bryson? Similar. What parts are equal in similar polygons? This is not something that was emphasized here, so let's think about it. Let's say we've got a goofy-looking pentagon. And let's say we've got another goofy-looking pentagon. And let's suppose they're the same shape. I think I did a pretty good job. They're probably not perfect, but it's pretty close.
Good job.
Are these sides equal, class? No. Are these angles equal? Yes. Specifically, the matching angles are equal. We have a term for this, and we didn't actually go over it yet, so I'm a little surprised they asked the question here, but I want you to go and write the answer down anyway. We call these corresponding angles. The matching angles are called corresponding angles, and that's what will be equal in similar polygons. The corresponding angles are equal. Number 17. What is the definition of a square? What makes something a square? Michael?
A rectangle with all of its sides equal.
That's word for word. A rectangle with all of its sides equal. Great job. Jot that down. A rectangle with all of its sides equal. Begs the question, what's a rectangle? Anyone know how to define a rectangle?
A rectangle is a four-sided polygon with two parallel sides.
Well, that's a parallelogram, a four-sided quadrilateral with parallel sides. And it does have parallel sides, but there's something that makes it a rectangle and not just a parallelogram.
A square that only has two,
Now, we wouldn't define a rectangle as a square for starters. Ben?
it's a shape.
Don't waste my time, Ben. Michael? Want to go 2 for 2?
A quadrilateral with all 90-degree angles.
How about we take her idea, which mentions the parallel sides? So we'll just say a parallelogram with all right angles in it. Parallelogram with all right. You don't have to write that down. That was just extra. Number 18. What type of angle has 180 degrees? Class? Straight angle. What kind of angle has more than 180 degrees, class? Reflex angle. They didn't ask that. Number 19. If two angles are adjacent angles, what two things need to be shared? So picture it. We've got an angle. We'll just call this angle 1. And we've got another angle. Call this angle 2. What do those two angles share? Luciana?
The side and vertex.
They share a side, specifically a side that runs between them, right? So they don't share like angle 1. If this were angle 2, they would share this side, right? But they're not. It's 1 and 2. They share a side between them, and they share a vertex. Good. So write that down. A side between them and the vertex. They share a vertex. They share a side between them. Number 20 says this. What is perimeter? What is perimeter? Let's go back to Ben for redemption.
It's anything around like a square.
Okay, or more generally a polygon. The distance around a polygon. The distance around a polygon. Now, why can't we just say the distance around a shape? Because what if the shape's a circle, class? We don't call it perimeter, we call it circumference. Because how do we find perimeter? How do we find perimeter in general for any figure? Corey, how do we find perimeter? I'm not looking for a formula. Just how do we find perimeter of any figure? Any polygon?
Add up the sides.
Add up the sides. You know what a curve does in half class? Sides. So you can't add up the sides if they know sides, so that's why we can't call it perimeter. But for a polygon, perimeter is at sum of all the sides. That's the distance around the polygon. Yesterday, we began talking, though, we transitioned from talking about perimeter, which is distance around, to looking at the space within a figure. What term refers to the space contained within a figure? Sam? Bryson? Space within a figure. Griffin? Area. Gentlemen, what is it? Area. The space within a figure is called area. And I said, if we were to measure the distance around the room, there'd be however many feet all the way around. But when you measure area, you don't measure it in feet or inches. You always use what kind of units for area? For redemption, Sam? Square units. Whatever the unit is, would it be squared? So feet squared, inches squared, centimeters squared, meters squared, whatever, right? And so we would measure area always in square units. And yesterday we only looked at two figures, the two easiest figures for finding area. We looked at the square and the rectangle. How do I find the area of a rectangle? Bryson?
A equals LW.
LW. We're going to multiply the length and width together. What about the area of a square? How do I find that, Kirsten?
A equals S squared.
There we go. So for our rectangle, A equals LW. For the square, A equals S squared, which means side times itself, remember. At your seats, I want you to do numbers 1 through 7 in the homework section. Do 1 through 7, the odd, in the homework section. So 1, 3, 5, 7 on page 179. You're already there, but in the homework section. 1, 3, 5, 7. Reviewing over areas of these figures, and then we'll get into our material for today. Griffin's got them. Michael's got them. Jalen finished? Doing just the odds. 1, 3, 5, 7. All right, looks like most of us are finished. We're going to go ahead and stop here and take a look at our answers. Number 1, what shape do we have here, class?
Rectangle.
Rectangle. Say the formula with me for the area of a rectangle. A equals LW, which means when the L and W are up against each other, class, that means we have to multiply them together. We're going to multiply the length times the width. What do we get for our answer, Luciana?
300 millimeters squared.
Good, and we're going to write the millimeters. They also get multiplied by each other, and so a millimeter times another millimeter is a millimeter squared. 300 millimeters squared is correct. Number 3, what shape do we have here, class?
Rectangle.
It's another rectangle. It's not as pronounced, but the sides aren't equal. So once again, we're going to use what formula, class?
A equals LW.
And when we multiply the length times width this time, what do we get for our answer, Corey?
108 yards squared.
108 yards squared is correct. How many had that answer for number 3? Now, if you had a square, could you use A equals LW?
No. Yes.
I mean, you could, but what's true about the length and the width? They're both the same, right? Because a square is, as Michael defined it earlier correctly, a rectangle with sides equal, right? So since a square is a rectangle, yeah, you could technically use the rectangle formula. It's just easier to think of sides squared. Number 5, go ahead and read the word problem for us, if you would, Elaine.
A rectangle flows in. Okay, I can't read. A rectangle floor is 36 feet long and 29 feet wide. How much carpet would be needed to carpet the entire floor?
So we basically needed to find out, since carpet is what covers the area, we really just need to know the area of the floor, don't we? So we find the area of the floor, and what did you find that to be, Elaine?
A equals 1,054 feet squared.
Really close. A little mistake, Kirsten.
1,044 feet squared.
1,044 feet squared. Just a little carrying error there, I believe. And number 7, class, what formulas are used to find the area of a rectangle? We've said it twice already. Let's say it one more time.
A equals LW.
And for the area of a square.
A equals S squared.
Excellent. Next thing in your notes, if you would, go ahead and turn the page, and let's talk next about the area of a parallelogram. The area of a parallelogram. I've drawn roughly a parallelogram on the board. Again, my art skills aren't perfect, but I want you to picture this. If I were to, the issue with the parallelogram, of course, is that it's not all nice right angles like a square or a rectangle, correct? And so, but if I were to draw this line right here that is perpendicular, that does make a right angle, if it makes a right angle with one line, it's going to make a right angle with the other line also, won't it? Because the two lines are parallel to each other. Now imagine for a moment that I took my eraser and I erased this off. Better yet, let's suppose I got out a jigsaw and I cut it out of the chalkboard. I mean, that would be really bad for the board. And let's suppose I moved it right over here. Now this line and this line are parallel to each other, right? So that means that when I move this line, it would line up perfectly, wouldn't it? And then this line would come over, and however big it was, is how big it would copy over, right? And then this line would copy over just right there, and then this line would copy right there, and all of a sudden now, this is no longer where it was. I've copied it over here. What shape have I made, class?
Rectangle.
A rectangle. Now, the length that I cut off is simply the length that was tacked on. So the size of this baseline, has it changed?
No.
No. Nothing has really changed. It's the same amount of area, but I've now transformed, so to speak, my parallelogram into a rectangle. Which means then that the formula for the area of a parallelogram is largely the same as the area of a rectangle. Rectangle's length times width. Well, this length across the bottom doesn't really change, but the width. Well, you realize the slanty line really isn't the width, is it? It is what we would have to use for perimeter, but what we really want is not the slanty line length, but the actual distance from the bottom to the top, right? For instance, if I wanted to measure how high is the ceiling, I would take my tape measure, right? I would hold it down on the floor, and I wouldn't measure to over there on the ceiling, class. I'd have to measure to directly above me. That's how we measure the height here, correct? We refer to this line as the height of the parallelogram, or another term that you'll see is the altitude of the parallelogram, right? If you were in a plane and say, hey, how high is the plane flying? Well, we're at an altitude of 30,000 feet. Okay, altitude means height. So if we were to take this length, if you will, we could refer to it as the base of the parallelogram. It's the side that it's sitting on. So we would say then that for a parallelogram, and you see this in your textbook there, the area is equal to the base, which is what the length of the rectangle would be, times the height of the parallelogram, which is essentially what the width of the transformed rectangle would be. Say that formula with me, class, but use the words instead of the letters here. Area equals base times height. Again, area equals base times height. Now, in letter form, class, we could just say A equals BH. So look at the picture that you have there on the example problem. They give us this parallelogram. How big is the base of the parallelogram on example 5.2a, class? 30 meters. Now notice, they don't tell us the slanty length because we don't care. We ain't finding the perimeter. What I care about is the perpendicular, the actual height of the parallelogram, class. They say that it's 12 meters. Make sure you're looking at the example problem in your book there, Jalen. And so to find the area, class, we use the formula A equals BH. So they multiply 30 times 12, and you see that they got 360 meters squared. Seemed like a pretty easy formula to use. Just remember, you don't care about the slanty line when you're finding area. Look at the next picture. A little scale drawing that they could form here. Well, first of all, how many boxes across the bottom of that green parallelogram, class? 7 boxes. But every box, according to the little scale off to the side, is how many units long? 2. So really, it's not 7, class, it's 14. The base is 14 units. What about the height? How tall is the parallelogram? 3 units. Well, 3 boxes, but every box is 2 units. So we'd actually say that the height, class, is 6 units. And to find the area of the parallelogram, class, we use the formula A equals BH. So they multiply. 14 times 6, they got 84 units squared, or 84 square units. Questions on parallelogram? You see, it's really no harder than rectangle, because really, it is a rectangle. It's just been slantified. Questions? All right. The next thing I want to look at is the triangle. The triangle. So imagine for a moment we've got this triangle here. And let's suppose for a moment that I took a piece of poster board and I somehow was able to cut a triangle exactly this size on a piece of poster board. Now imagine I take the poster board and I flip it so that this line on the poster board lines up right here. Well, that poster board triangle would also then have this piece is now flipped up right here. And this piece is now flipped over here. It's poorly drawn, but you see what would form? If you just copied any triangle and flipped it over itself, you would form, class, a parallelogram. Well, this parallelogram's area is equal to base times height. This base times the perpendicular height, correct? But the triangle isn't that big. This is actually 2 of the triangles, class. So we would say that the triangle is only how much of the parallelogram that we see? Half. A triangle is only half of a parallelogram. Does that make sense? So therefore, for a triangle, its area is going to be 1/2 its base times its height, or altitude. Does that make sense? Now look at the picture that you see there. They show this with the little blue triangle there. They show a congruent triangle flipped over, and you see that blue parallelogram outlined. What do you do, though, when you've got a triangle, an obtuse triangle, where the altitude is like, how do you measure the altitude? It doesn't even land inside the triangle, does it? No, but this length would still be the base, just from there to there. If you extend it out a little bit, now you can see what the height would be. So that is always perpendicular, even if it falls outside a triangle, that's okay. Heights can fall outside the triangle. But that's still how we would calculate the area of the triangle. Class, say it in words with me first for the area of a triangle. Area equals 1/2 base times height. Again, area equals 1/2 base times height. Now with letters. A equals 1/2 BH. Now, we can be really smart with the 1/2. Look at the next page. Look at the example at the top of the page. Example 5.2b. Sorry, you don't have to flip the page. Sorry, I'm flipping my book over. You don't actually have to flip the page, just the next page. Example 5.2b. Look at the little triangle thingy there. It shows, first of all, on our green triangle class, how many boxes do we have to count across the bottom?
3.
I'm counting 5. 1 box, yeah, 2, 3, 4, 5. I got 5 different boxes counted over. But it says that every box is how many units big?
4.
4. So really, class, what is the base of the triangle?
20.
20 units. Now, let's take a look at the red line, the altitude, the height. How tall, how many boxes tall is that thing?
4.
4, but again, each one is technically 4, so what's the height or altitude of this thing? 16 units. And we know that the area, watch, is 1/2 the base, 20, times the height, 16. Let me tell you what you're not going to do. What you're not going to do is multiply big numbers together and then try to cut it in half. No. We can be smart because mathematicians are lazy. Instead, we're going to cut one of the numbers in half. We're going to use the half up front. Which number might be really easy to, well, actually they're both easy to cut in half, but strategically, which is the better number to cut in half, Bryson? The 20. Because if you cut the 20 in half, class, you really just have a 10. And 10 times 16 is so easy. 160 units squared. Now let's say, Mr. Adasky, I believe it would to be easier for Sooth if I did cut the 16 in half. Okay, smart Alec, let's cut the 16 in half. What do you get if you cut a 16 in half, class? 8. And maybe you think in terms of $20 bills all the time, so to you, 8 $20 bills equals how much money? 160. Same answer. Let's first but Mr. Nadasky, I'm a nerd, and I really like working with large numbers, and I am not lazy. I would prefer to multiply 20 times 16 first. Okay, what is 20 times 16, nerds? I don't have enough. 320, we do have a nerd. Great. 320. And then cut 320 in half. What's half of 320? It's still 160. It really doesn't matter which way you do it, but if you can strategically make your life easier by cutting one of these numbers in half. Let's suppose, for instance, we had a base that was 11 units. And let's suppose it was a little shorty that was only 4 units tall. Well, again, what's my formula for the area of a triangle, class? A equals 1/2 BH. Which of these would be easier to cut in half? 4. The 4. Cut the 4 in half, class.
2.
Now multiply it by the base.
22.
22, we can do it in our head. As opposed to 4 times 11, 44, and then cutting that in half. It's still 22, we just get smaller numbers this way. Does that make sense? But you can only use the half once. You can't cut the base in half and the altitude in half. You cut either the base or the altitude, or you multiply and get your final answer and then cut that in half. Only one time you get to use the half because there's only a single half in the formula. Everybody got that? All right, turn the page. I want you to tackle 1 through 7, the odd, now on page 182. 1, 3, 5, 7, this time on page 182. Always square units when we're finding area. Yes, always square units. find out. All right, pencils down. Even if you're not finished with these, let's take a look. Number one, first of all, what shape do we have here, class? Parallelogram. In class, say with me, what's the formula for the area of a parallelogram? A equals BH. So, we plug in those numbers for A equals BH. In for the base, we're going to plug in what, Jalen? 21 hectometers. And in for the height or altitude, we're going to plug in, Bryson?
13.
And since these things are up against each other, class, we've got to multiply. So all we got to do is multiply 21 times 13. What do we get, Luciana?
273
And we're multiplying hectometers times hectometers, so my unit is?
hectometers squared.
There we go. How many had 273 hectometers squared for number one? Questions on number one. Look at number three. What shape do we have, class? Triangle. Now this is a funny triangle, class. It is a special type of triangle. It's a right triangle. And those two lines are perpendicular already, which means, yes, obviously, class, the base of the triangle is 5 miles, but the 12 miles is the height or the altitude, right? So when we go to our formula for the area of a triangle, class, A equals 1/2 BH. We're going to plug in for the base the 5 miles. It's a really big triangle. And in for the height, we're going to plug in the 12 miles. Now, strategy tip. I can easily cut which number in half, class?
12.
The 12. Take half of 12 to get.
6.
And now it's just 5 times 6, class?
30.
30. And of course, we'll leave our answer as
Miles.
miles squared. There we go. Looking at number 5. Parallelogram, A equals BH. What do we get for our answer, Ben?
Which one?
Number 5.
Okay. 400 meters squared.
400 meters squared is correct. And then, they're mean. Number 7. They give you a triangle. We're supposed to use A equals 1/2 BH. And they give us a base of 15 feet and a height of 9 feet. And which one can I take half of, class?
None of them.
There's really neither one that's easy to take half of. It might be the better part of wisdom than just say, okay, you know what? 9 times 15 it is. What is, we'll just take this first, 9 times 15, anyone?
135.
135. And then cut the 135 in half by dividing it by 2. You could multiply by 0.5 if you wanted to, but I think it's easy to see that 2 goes into 13, class. 6 times with 1 left.
7.
2 goes into 15
7.
7 times with
1 left.
1 left. And we could leave our answer as 67.5 feet squared. You would also get that if you multiply by 0.5, 67.5 feet squared. It's up to you which way you want to do it, but if you can't cut a number in half, either multiply by 0.5 or divide by the 2 at the end. Either of those would work. How many figured that out, that you'd have to do that, and got 67.5 or 67.5 feet squared? Questions at all on that? Drop down and do numbers 9 to 13 now with some scale drawings. Let's see how we do with the scale drawings. 9 to 13, the odd. 9, 11, 13. few people already finished. Take another minute to finish if you're not. Trying to get airborne? Taking that, I'll fly away a little too little. Don't actually fly. Like if I could fly, I could dunk. That's true. Just think how nuts that would be. Shock the other team playing basketball. Michael rises and rises and rises and rises and rises and then dunks the ball. All right, let's see how we did on these. Number 9, they made life easy on you. Every box is just a unit. Now, the downside is you had to count. And how many units long is that base, Griffin?
13.
Oh, it's not 13. You're just a little bit off. It is not 13. It is 12. Now, here's a quick tip for you. Don't count the lines, count the spaces. So I've had this problem with when I've taught 8th graders in the past as well. So let me kind of show you something real quick. Let's suppose we've got our grid work here. Okay, we'll just kind of make up a grid. And let's suppose we have a line that is, let me put it in orange to make it a little easier for you to see different from the grid. What my students like to do is they would start here and they'd say 1, 2, 3, 4, 5, 6. But do you see that you're counting lines when you do that? We don't want to count lines. So what I encouraged them to do was to take their pencil and kind of 1, 2, 3, 4, 5, like that. That way you definitely get it counted correctly. There are 1, 2, 3, 4, 5 little spaces on the board. So do you see that? So you might do that now, and again, look at that again. Okay, 1, 2, 3, 4, 5. Should have 12 spaces along the bottom. How many spaces tall, class? 3. Again, 4 lines tall, but 3 spaces tall. And so if we multiply base times height, what do we get for our answer, Griffin?
36.
Should be 36.
Squared.
Units squared is correct. Good. Turn the page. It almost looks like an equilateral triangle. It looks really close. Doesn't really matter. We're going to measure how many spaces across the bottom, Kirsten. 5. But that's really how many units long. I forgot about the scale. What should it have been across the bottom then?
Not 15.
You said there's 5 spaces and each box is 2 units a side. So 5 spaces, 2 units each.
2 units?
That's what it says on number 11.
Oh, 11?
We're on number 11 right now.
Oh, okay, I understand.
We were doing 9, 11, and 13? You didn't do number 11. Oh, okay. Well, let's go to Ben. Ben, how many units total should the base of our triangle be on number 11?
5.
Well, it's 5 spaces, but each one's 2 units. I feel like we're stuck in a rut here.
10.
10. There we go. Okay, so the base is 10 units. How many boxes tall is this triangle?
8.
Okay, it's 4 boxes, which is a total of 8 units. Okay, I was going to get there in the next question. So we now need to use our formula for the area of a triangle. Class, what's our triangle formula? A equals 1/2 BH. So we take half of 10 times 8. Which one do you want to cut in half, Ben?
8.
8. To get?
40.
4, and then we multiply to get 40
Units squared.
There we go, 40 units squared. How many have that for number 11? Number 13, how many little spaces do we have across the bottom here? Bryson?
5. No, 4.
4, and each one's 2. So technically the base of our parallelogram is 8. How tall is the parallelogram?
4. I mean 3.
3 boxes, which means technically
6.
6 units. So if you have a base of 8, height or altitude of 6, and the formula for the area of a parallelogram, class, is?
A equals BH.
We're just going to multiply the 8 times the 6 to get, Bryson?
24 square units.
8 times 6.
Oh, I did this wrong. 48.
48 square units, or 48 units squared. Pay attention to the little scale thingy that they give you. Questions? How many got all 3 of those correct? All right, I want you to do 2 to 14 now, the evens. We did all the odds, kind of little sections at a time. Now do 2 to 14, the even. And little things that we were struggling with, like forgetting to pay attention to the scale or counting spaces wrong. That's okay, right? The important thing about life is that you learn from mistakes. It's not a problem to make mistakes so long as you learn from them. So let's see if we've learned from them. Let's see how we do on these even problems, 2 to 14. Are you done? Make sure you include your units with your answers. Get in the habit of doing it correctly so on a quiz or test we get it correct and don't lose points. Yes, sir.
Do you count these kind of boxes or no?
So you're only focusing on the base and height, right?
Yeah.
So 1, 2, 3, so forth.
So you count the like slightly covered boxes?
Yeah, anything that it is included with the figure. Few people already finishing. Take another minute and a half or so to be working. Just a little longer for those who are still working to be finishing up. All right, let's take a look at these. Pencils down. Number 2, what did you get for your answer, Jalen?
2, I got 120 yards squared.
120 yards squared is correct. Number 4, what did you get for your answer, Bryson?
63 inches.
You multiply base times height, but for a triangle, we need to remember to multiply or take half.
Oh, half, yeah.
1/2 base altitude. So we need to cut your answer in half or multiply by a 0.5. And what will we get for our answer?
31.5. unit square. Or inches square.
31.5 inches squared. There we go. Number 6. What do we get? Luciana?
180 centimeters squared.
Yeah, it's not a triangle. We don't need half. We just literally get to keep the numbers. 180 centimeters squared. How about number 8? Michael?
45 kilometers squared.
45 kilometers squared is correct. What was the problem?
I was trying to find my answer.
Oh, okay. Make sure we work neatly. 45 kilometers squared is correct. Notice on 2, 4, and 8 class, we had to use the half base times altitude. On number 6, just plain old base times altitude. Right? You see, you have to keep associated which figure, which formula. Just like we did, by the way, with circumference of the circle. Right? Is it a diameter or radius? Use the right formula. It'll tell you what to do. Same thing's going to be true with these area formulas. Number 10, Kirsten, what'd you get?
16 units squared.
16. How big is the base?
8.
On number 10?
90 units squared.
How big is the base on number 10?
18. Oh, no.
How many little boxes on number
Not
10?
18. 5.
5, so because each thing is 3 units.
It's 3 units. 15.
15, there we go. So we needed 15 units across the bottom. How tall is the parallelogram?
4.
4 boxes, so each box 3 units.
16. I know 15.
4
Oh, goodness, 4.
times 3.
15.
4 times 3?
4 times 3. 12.
12 units. I'm not letting our science teacher show any more videos or movies in class before you come to me. Y'all are too tired and sleepy. All right, so we should have multiplied 12 units by 15 units. Who did that? You multiplied 12 by 15. All right, Elaine, what did you get?
180 units squared.
180 units squared should have been our answer for 10. All right, Kirsten, redemption time. We got this. You're looking at number 12, right? You're looking at number 12?
Mm-hmm.
All right. How many units across the bottom?
8.
Count again.
7.
On number 12.
On number 12.
The little green triangle. we go get this. Okay, so, ready? Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9. See, because it starts here and ends here. So it's 9 boxes. All right, so how many units across the bottom? How many boxes across the bottom?
9.
9. And everything's 1 unit, so it really is 9. Okay, how many units tall is it?
2.
2. But we get to cut it in half because it's a triangle, so it's a half BH. Let's cut the 2 in half.
1.
1, and multiply that by the 9.
9.
9 units squared. Should have been our answer there for number 12. Number 14, what did you get for your answer, Sam?
I got 40 units squared.
How many boxes is the bottom?
5.
5, but it's actually 4 units each. So really, how big is the bottom?
20.
20. So the bottom's really 20. How tall is it?
4.
4, but it's really
16.
16. All right, so we need to take our formula. Half base times height. Which one should we cut in half?
20.
The 20 to get,
10.
and then when we multiply, we get
160.
160 square units. How many perfect 7 for 7 on these? How many 7 for 7? How many 6 out of 7? 5 out of 7. Questions on these even numbered problems? Yes, sir.
Can you just divide by 2 on one of the? So you know how like for number 10 you could.
For number 10. Okay, so we're looking at the yellow one.
Yeah.
Okay.
For the 12, couldn't you just divide that by 2?
Oh, okay. What shape is this, class?
Parallelogram.
Parallelogram. What's the formula for the parallelogram?
A equals BH.
Not a half BH. Triangle's a half BH. Don't cut in anything in half on a parallelogram. For that matter, for a rectangle, class, what's the formula? A equals LW. Do we cut anything in half on a rectangle?
No.
What about a square? What's the formula for the area of a square, class? A equals S squared. Do we cut anything in half on that one? So the key to remember is only on the triangle, class, our formula is A equals 1/2 BH. Of these first 4 polygons, the only time we even have to think about a half is the triangle. So basically, in your mind, associate triangle with frustration. Okay? If it's a triangle, I have to try harder because there's a half. I don't know. Whatever you got to do to help you remember, okay? But find a way to remember triangle as the half. Nobody else does. So triangle is like, oh, it's one of them. Okay, I'm going to cut something in half here. Wherever all the others, we just leave it alone. Yes, ma'am.
So it's not really a question, but for the weird purple one.
The purple triangle.
Yeah, 14.
Yeah, number 14.
Yeah, I feel like you use that for like an example.
We sure did.
Yeah.
Yeah, we did do that. Good. Any other questions on this? Flip back to page 179. Flip back to page 179. Do numbers 8 to 14 at the bottom of the page. Do 8 to 14 at the bottom of the page. Page 179, 8 to 14 at the bottom of the page. All right, let's take a look at our answers here. Number 8. What is the name for a 5-sided polygon, Griffin?
Pentagon.
Pentagon. Number 9. What is the supplement of a 45-degree angle, Corey?
The supplement 135
135 degrees. Number 10. What is the proper notation for line AB is perpendicular to line XY? Elaine?
So it's like AB and a line over it with 2 arrows, and then like an upside down T, and then XY, and then a line over it with arrows.
Perfect. Number 11. What is the vertex of angle LMN, Sam? M. What is the definition of a rectangle? Ooh, I asked that a little early, didn't I? Ben?
I don't
I
know.
found a friend. Kirsten?
A four-sided polygon with 2 parallel sides.
That would be a trapezoid. Michael, you actually gave us the definition earlier. Let's go to somebody else like Jalen wants a second shot at this thing.
Parallelogram with all right angles.
Parallelogram with all right angles. Good. Let's come back to that on number 13. What kind of angle is less than 90 degrees?
Acute.
And number 14, if this that was acute for those listening. If the side of a square is 10 centimeters, what is the perimeter of the square, Kirsten?
40 centimeters.
40 centimeters. Class, if the side of the square is 10 centimeters, what's the area of the square?
100.
100 centimeters squared. All right, your homework for this evening. Homework for this evening is to do page 179 in the homework section, 2, 4, and 6. And then on page 182 or 186 in the homework section, do 1 through 12. Page 179 in the homework section, 2, 4, 6. Page 186 in the homework section, 1 through 12. Have a wonderful rest of your day. You are dismissed.